Yeah, I haven't been able to respond to emails because of lack of time and all. Just quickly have a look if there's anything. Yeah, I got some email that people couldn't connect with the MySQL for some reason. You have to remove that semicolon to enable that. Other than that, it should be exactly as it is with the with what you did in Alacritas, so there shouldn't be any problem. Um, Everything else. One other thing is obviously that we'll be changing the instead of local host, we'll be using a different IP address in the tutorials, maybe some other username and password and all those things. But yeah, other than that, it should be the same exactly with the Alacritas. We'll have a look at it. Brand, yeah, other tutorial. Yeah, so I mean, this week's tutorial is technically due next week's tutorial. So like, if you have something this Wednesday, you have to submit it by next Wednesday. However, for the first tutorial, we are kind of a bit more lenient because like there is no, I mean, a lot of you have faced like, because it's a cloud thing and it depends on the external resources, setting things up is probably the biggest hurdle that you face at the very beginning. But you cannot do anything. I mean, you have to set that up anyway. And after that, it's all programming, so it kind of becomes a bit more easier to handle like the previous ones. But yeah, so for the first one or two tutorials, you might go a bit easier. But after that, it's always due like at the end of next tutorials. So how are you going with the tutorials? Is it all good? Like any issues regarding the tutor or anything that you want to, any feedback, anything you want to give me? Or anywhere we can improve it. The thing is like for everybody involved, like Mutas did this last year as well, so he's very good on top of it. But the biggest issue that we are all facing is that it's online, so we have to rethink everything for online perspective, and that's kind of like a problem for everybody, I guess. Yeah, okay, so let's get to the actual discussions for today. Today's discussion about web services. So the web services is, or what is service-oriented architecture? This is a concept. There are a lot of different programming or platforms or whatever technologies, rules developed around this concept of service-oriented architecture. So it's an architectural approach for designing distributed application. So a bit of background on this distributed is that like before we had this cloud computing concept, everything had to be done through things called RPC. So throughout the late 1990s and the early 2000s, until 2005, 2006, when there was no concept of cloud thing as such, the idea was that, and back then computing was, I mean, the systems were not that powerful. I mean, you can imagine we had Pentium 4 until say 2002, 2003, which was like about 1/10 of the power of whatever you have at the moment. It's probably weaker than what the laptops that you use. And then we had different other machines at that point. Core 2 Duo, I think, came out, like the first dual core mainstream, like for public use stuff came out, I think around 2005, 2006. I may be wrong with the dates, but yeah, it was pretty late for the, I mean, at that point, the consumer side stuff was not very powerful. Obviously, big companies had bigger machines, but even then, their big means that they had more machines connected to work out. So, but from like a single user's perspective, like common users, the machines were not really that powerful. However, people's computing needs became larger. Like you could not run everything on the same sort of like in your one PC, and so you wanted to shift out some of these computing to some other platform. Like for example, anyway, for example, like even something like searching or that's like surfing the web or say emails and stuff. Initially, when we were using HTML1 and HTML2 and stuff like that, it was okay to run on your own PC and all. But gradually, when things become more computing oriented and like you wanted to search your emails and all those things, it kind of became obvious that a lot of the computing needs to be done at the server end, like all of the like, and it required a lot of flexibility in the software at the server end, or whoever is providing that service essentially. So that's when the cloud thing started coming up, and by 2010, 2012, there was a full fledged like efforts going on around the world across these big companies, like the tech companies like Microsoft, Google, and Yahoo, and a lot of those things. They kind of started up this like providing their online service as a more market-oriented or easily approachable, easily consumable thing on the internet, and that thing is essentially what we call services. So that means that browser is one thing, that's perfectly fine, but running everything as HTML became very difficult, and it became like a bit of a like overhead. There was a lot of things that you couldn't do with the just HTML. I mean, a lot of things went in the background regarding the computing services and all of those things, and they had to be like put into some kind of specific order. Like you couldn't just like if it's like selling something. If you have like if you're selling in something in a shop, like say for example Coles or Woolworths, they are selling say groceries and a lot of these things in the shop. They have to maintain some standards. Like you cannot like just sell anything and then just expect that people will pay the price for that thing. And it's a competitive thing. Like Coles and Woolworths are always like looking at each other and changing their price tags and trying to bring in better products and all those things. It's the same kind of mentality or same kind of thing that goes on with these tech companies. Like when you are doing it online services and all of these things, you're essentially selling your services or selling like your computational capacity or your algorithms or any programming that you're running with your customer. And once again, it's the same thing. You have to have some kind of like concrete architecture, a method to evaluate whether you are running things correctly or not, whether you are adhering to like the rule, like the laws and the rules and all those things, and how good your service is. Like, is it like dropping down a lot of times, or all those things? It needed to be sort of had to be laid down as something that is quite exchangeable. So you can actually measure all the different companies with the same kind of rule and all those things. So that's where the service-oriented architecture comes in, essentially. As a term, it's a small thing, but obviously there's many different things you can find within the service-oriented architecture, like different kind of architectures would fall under the service-oriented architecture as well. We'll be looking into two different things like the SOAP and the REST in this unit as such, but there could be other things that you could come up if you are doing things in the industries. So theoretically, this is what service-oriented architecture is. So it's an architectural design approach for distributed applications. So if you have one client there and the client doesn't want to do all the computing, so how does it send its request to other nodes in the network to do the computing, and they will take the input and they will give some output. Now this has to be standardized. That standardization is the entire service-oriented architecture. So the other thing was that the services could consume each other as well. So the client initiates a service, and service can call another service, and then call another service, and then ultimately the reply comes back through the chain and comes back to the actual client. So the benefits are this platform independence, which is a very important thing in terms of the computer networking, is that your browser could be running on Windows. You need to be able to access something that's running on Linux, and that may be consuming something from a Mac machine, or even within Linux, it could be like a lot of different server OSs and all those things that you have to take care of. So it's platform independent, it's loosely coupled, so it's like you don't have to use everything. You can use some things and you can ignore some other stuff, and that's what loosely coupled means. Reusability means that you can keep it's like if you have implemented a specific amount of like specific code for say checking your password, you can use that code for multiple other modules. So you can just easily reuse the code, or you can just integrate it into bigger system and then integrate that system into another bigger system and all those things. Extensibility also becomes kind of easier because of the modularity itself. Because if you can divide your entire service into different, like if your entire business, what you want to sell, all the data and everything, you can actually now divide it up into different unique services and then go into microservices and all those things. And you can then add on more services as you want to expand your business and all. So extensibility is kind of, it becomes easy as well. And it's less implementation cost in general because of the last 3 points, that it's reusable and it's integrable, and it can be extended quite easily. So that's kind of the advantages of service-oriented architecture. Sorry, I had a question. Okay. You may send me an email. Maybe I can send you some stuff for what we covered in 202, and then you can probably make an easier one. But anyway, let's have a discussion later sometime. Okay, so SOA. So it kind of facilitates the so it's kind of facilitates the agility and the flexibility of business. So if you think about it, so this discussion was about the computing side of things. So if you are if you are managing a cloud service with the service-oriented architecture, then from a computing perspective, this is what you can implement, or this is how you think. However, from a business perspective, the SOA means a lot of the legal framework and all of those things comes in. We're not going to go into deep of that thing in this unit, but it does help you like change your business model kind of easily, and it kind of also helps with the flexibility in the sense that you can team up with another company. You can think about it like this: without this SOA or any kind of standard exchange between companies and the consumer and the companies, you would have to develop everything on your own, literally. So I mean, that's how the email services developed early on. Is that every tech company like the Yahoo, Microsoft, Google, and say the other companies, they set up their own email services. And back then, it was difficult to sort of have an exchange between different, like you couldn't use your Google to log into some other accounts and all those things. It was kind of difficult. But after that, nowadays, you can use your Google account to log into a lot of different places on other websites and all. And it's kind of easier to have this like mixing of different technologies together to create something that is like an end product for the consumer. Behind the scene, there might be services being consumed from here and there, all of those things. If you log into any website these days, you probably will see that. And if you press F12 in the network tab, you will see that there's plenty of Google services that are getting called, even though the website has nothing to do with Google. There's no Google in there. They're probably using Google API for analytics and all of those things behind the scenes. So all of those services are being incorporated in their business model to track like what you are doing with that website. So it could be a third-party website that is just using Google services within their business model. So this kind of things becomes easier with business. And you can, the thing is, if you are just if you have something that you want to do as part of your business model, and you have say 5 programs, you need 3 other programs. Well, you can either make it on your own, or you just say, oh no, okay, fine, I team up with somebody else, and I just ask I just pass on this request to him or the other company, and then get a reply back and send the reply back to my customer. So that's how this interoperability thing from a business perspective can happen. Obviously, if you have the SOA, then you will have some kind of modeling regarding the price tag and also you call this function or you call this web service 10 times, you pay me say $50 or something like that. Or I mean, there could be different price tags that put on the service and all those things like that. But so that's the business level model stuff. And then the thing is, like, because it's a service, you can actually stop subscribing. So like I say, company 1 wants to consume a service from company 2 for 2 days, and then okay, I've said, well, no, that's not running. It's like returning error a lot of times, so it's going 404 because your service is not up or something like that. So I say, okay, fine, your service level is crap, so I don't want to go with you. I will now consume the same stuff from another company or I level of my own. So you just change a link. That's all. In company 1's program, you just change a link, and that's then that start working. So that's the flexibility with the business that you can have. But what we need now is to do that is you have to well define these web services. So you need to have a proper, almost like you can think of this as a legal document, like is that if you are selling something as a web service, then you need to define it in a proper way so that the people who are complaining can complain that, well, this is not what I wanted, or this is what he said is going to work at a business level in our business meeting, but this is not exactly what we are seeing when we call your website or call your URL or the service-oriented architecture, networking, resources, and all those things. So you can compare that. So that's why it's kind of needs to be described well in terms of some kind of document. We'll see how to do that in some later slides. And we have to have a mechanism for registering and looking up these web services, descriptions, and all those things. So we have to register somewhere, and we need a standard method of invoking the services as well. So you cannot just call anything and expect that the output will be all good. So you need a format of requesting and a format of accepting what is the response that you get. Concept is very similar to what we did in the HTTP stuff for the normal PHP stuff and all those things. It's a much higher level stuff here. So it's just much more complicated, much more well defined, and all, not just the HTML stuff that you get. It's a much more computing oriented thing, not just the visualization thing that you did in your just HTML stuff in the previous image. So service-oriented architecture, this is a formal definition. You can find more details in the IBM there, like the website there. It's really if you look at the standardized description here, then you find that the operational system, just multi-layered kind of thing. You can think of this comparing to the ISO OSI layering kind of concept. This is different. It's not the same thing, but conceptually, you can think about it like that you've got operational systems layer for the support, infrastructure support to SOS solutions and all those things. And then you've got the service component built on top of that. So you can then like the actual service description and all of those things. On top of that, there is the service layer, which then calls on the service component layer to get all the resources whenever they're needed and all those. And this kind of contains some of the logical services that you can actually call. So these will contain the actual URLs and stuff at this level. Before that, it's really could be some functions and all those things, and some whatever, like you have the operating system, like maybe some memory requirements and all those things that you can have at this layer. Then there's the business process layer for composition of Ruby supple. So this is where we kind of say mix up different web services and all those things that you can do in the business process, reflecting the business ideas, concepts of when you are implementing that thing. And then there's the consumer layer. So that's essentially and how to consume whatever you are servicing. That's essentially the consumer layer stuff. Then we have got web service technology. So the web service applications are developed using various programming language. So I mean, it's not really a single program-oriented language, and you do it in Java. You can do it in any of the .NET platform programming languages like C# and all those things. You can do it in PHP as well. So this concept is platform independent as such. It's not and you can implement a service in one platform. You can consume it in another one. We'll be running mostly everything on PHP, but you'll see some example on how to do it in using Java and PHP later on. So how can these applications be able to communicate with each other? So we can use this kind of we define a client object in whenever at the client end, and at the server end we have got the server objects and whatever, like the server web service objects and all those things. And then we use this WC3C defined concepts, like the same thing like the URI, so resource identifier, and we send a request in some kind of XML format, and you get a reply back in some kind of XML format, and then we parse it in the background. So it's just, instead of, I mean, everything is running on the TCP/IP protocol as such, but it's just that we are sending a lot of different kind of flexible kind of messages from one side to other, and then from the service side to server side, we're getting a reply in form of some kind of XML format, XML or JSON. We'll see that sometimes we instead of XML we can use JSON as well. Although SOA is primarily for using XML format as such. So why use this kind of web services to begin with? I think I kind of described that at the beginning. It's like this is more for remembering for exam kind of thing. So why use web services technology? You can expose the existing application with any zero changes. So this is one other thing, is that it's kind of, using web services, it's kind of easy to exchange or like change your standalone application into web applications as well. It was a bit difficult when we started with cloud computing, but nowadays it's very smooth. For example, if you have written some code in Java and you are running that on your machine for say last 5-6 years, and it was running okay, but now you would, instead of actually giving that code to your customers to run or something like that, you say, oh, no, you don't have to run it. I now can run it on the web as a web service. So you essentially just bring all those Java classes or Java programs as is. You copy it from a standalone program and put it inside a web service, and then just package it with the web services URL and all those things. And inside that, it will run exactly as it ran as a standalone non-cloud computing platform. So this is another thing that you can very easily do with just any existing applications. You don't really need to change the application side of any code in there, and you can just put it on the web for everybody to use it. A very classic case of this is like a lot of these companies are now moving to the cloud-oriented architecture. Is that, say for example, Office 365. Microsoft used to sell Microsoft Office as like in CDs and DVDs before. So essentially, up until like 2013, I think you could just get, I can't remember when they started the Office 365, but like up until I think the Office 2010 came out, the 365 wasn't that popular. It probably existed, but you literally had to buy a license, like 5 PC user license or something like that, to actually buy that and use that in there. Obviously, bigger organizations like universities would then buy a bulk license, and then they would be just using it through the TeamSpark and all of those things. Like it was a one service model where you have to download and install everything on your own machine independent. However, nowadays, if they have just moved that Microsoft Office, everything that you can do on a standalone desktop application of the Microsoft Office now, you can do exactly all this, pretty much everything on a browser through web services. So they have provided their entire Microsoft Office suite as a web service. That is the Microsoft Office 365, which you can run using web services. And then they went back and integrated that services into their Office 365 standalone application as well. So if you install the Office 365 on your machine right now, you can run it as a standalone. Like this PowerPoint is running as an application here. However, this is not just running on my machine here. It's actually a lot of this data is connected to the OneDrive, the cloud services, and all of those things. Any change I make here, if it's on the cloud, other people who are connected to this service here, this PowerPoint service here, they can also see those changes immediately. So all of this is possible because of the connected nature through all the web services. So this machine here calls a web service to make a change. Or like if I change something here, it will call a web services and also web service, and that will make a change on a file on the cloud, and that will be reflected everywhere else. So this is how things run. There are other companies like Amazon, not Amazon. Yeah, Amazon is obviously cloud. Adobe was probably the biggest change in the sense that they kind of stopped selling their standalone programs altogether. Everything that you want to do with Adobe now has to be like a cloud-oriented stuff. So literally, you have to subscribe, and then each month you have to pay a little to get their service, use their service and all. So you can do that kind of a bit easily with the web services technology. However, it's like services are loosely coupled to service customers. So the thing is that previously, if you had bought something on a DVD or a CD or something like that, you had to buy whatever you had on the DVD and CD. You cannot just choose between that. However, with this kind of web service technology, you can actually now be picky. Consumers, and the consumers doesn't really mean that end consumers like you and me, like who are actually like absolutely end user ones. Consumer means that there could be like different companies that could actually think about, well, I want to extend this part, I want to extend that part of the services, but not the whole package and all. So that becomes possible. Obviously, anything that has been made as a service can be reused again and again and again. Obviously, there are some updates will be required. Less implementation and communication cost. Well, this kind of is a issue with web services is that usually if it's well implemented, you would have less implementation and communication cost. However, if the services are not created properly, it could actually be counterproductive because you may have to change your service architecture multiple times, and then you would actually have a lot of the additional cost to do that maintenance and all of those things. This is a problem with being in a tech company as such. And this is where actually a lot of the companies either fail or succeed. Like for example, Yahoo, it's probably not so good in terms of this kind of properly implementing services. And a lot of the time services go down, you don't find it or you don't find what you want. And that just like brings down the reputation of the service provider, and then that essentially means that less consumer or less customers are just going to use their services, and they're going to move to Google and Microsoft and all those things. So this is obviously a good side of things that you can actually implement. You don't have to implement much once you have set everything up. But if you haven't done it correctly, you have to go back and change it multiple times. So that's why when setting up web services, you need to follow like all of this planning and everything. You need to break down into layers and think about, well, this is my business goal, business process, and so what do I need in the background? If this planning is not done at this level initially, you might end up with a business service that is not actually working correctly, and then you just end up with big problems there. Okay. So any questions so far? So there are two types of web, I mean, there could be other types, but we just look into the two types of web services like the REST and the SOAP. So any questions before we go into something more deeper? So anything that I've discussed until now is essentially more theoretical in nature. It's not really like we implement this theory as the SOAP and the REST, and we'll be doing this in the next tutorial. There's a SOAP and the REST example that you have to implement. But other than that, it's kind of theoretical, more final exam oriented stuff here. And this is pretty important. You can expect something within these few slides here. Okay, so SOAP's idea is that we have a web service provider and that publishes a service. Like it's pretty much like selling vegetables. Okay, my SOAP sells these things. You can buy it if you want to. The service consumer has to find that service, or this is exactly what I want, and then it finds and invokes the service. So essentially, the consumer creates an object. So this is very object-oriented concept here. So if you haven't done anything like object-oriented means that you define something as class, which is what you did in the previous tutorials. You define something as a class, and then you create an object of that class. So in this format here, we are essentially splitting up the concept here. So this service provider will provide the class. The object will be created at the other end. In the service consumer end. So service consumer actually creates an object, but it doesn't have the class defined here locally. So the class is defined here in the service provider side, and the object has to be created here. So it will just ask for the information regarding how to create this class or how to create this object, and this will respond through the web service where this will be created here. the object. However, each time there is any kind of service that has to be invoked, it will then again call it on the other side. So it's actually going to like ask this service every time that it try to execute a function associated with that object. So it has to actually call whatever is in there. So the stuff is actually executed here, but the representation of that class as an object is stored in this side here. So this is why we need these web service concepts, stuff, and all those things. Any questions regarding this model? Because this is kind of the fundamental and very important part of the SOAP web service. So that stands for Simple Object Access Protocol. So you have got the classes defined here, and that is registered on a web service registry here, and the consumer finds that as a URL and then calls that URL to create an object representation on the consumer side. Then after creating that object thing in here, it can call these functions associated with that object. So you could just say get name and like get age or anything like that you did in the, or we saw in the previous examples in the last lectures there, we can call that, but it's executed here and then we just get the reply back every time. So with this SOAP is that data format is XML. There can be exceptions, but pretty much it's standard that SOAP is always on XML. And then the communication protocol, it's called SOAP, so it's the Object Access Protocol. Then we have another thing called the WSDL. So this describes the web service, web service description language. And then for the discovery or finding the service, you use something called UDDI. So these are 4 terms that are associated as part of this SOAP architecture overall. So what is XML? I think all of you should know what is XML by now, but just revising that thing again. So XML stands for Extensible Markup Language, or like it just defines everything as part of tags with elements and attributes and all those things. And there are different tools that can be used to extend this thing. So you have got the document object model for XML as well. So it loads the entire XML and creates a tree out of that. So the root and then the like subsequent elements and then like that. And you can also read it sequentially if you want to, sequential access of XML. Then there is something called XSLT. So it kind of transfers from one XML language to another. So it's essentially, I mean, because obviously XML is you can express different XML structures with different things called schemas and all those things. If you want to differentiate or match those things, you can use XSLT. There are other things like XPath and XQuery. These tools can allow you to query the XML and using XML and all those things. Now, so this is the most important thing. This is the most important thing with this SOAP concept is that the XML schema defines what you should have in the web service. So the schema is what defines the structure. So essentially, if you're asking for a function that requires 2 parameters and should return 1 parameter as an output, then that is defined in the XML schema. So well, this function is going to take, this is the function name, it's going to take 2 parameters A and B, will return C as a string type, and the input type will be say two strings and something like that. So whenever a request is made, it will be matched again this XML schema that all the request actually conforms to all the object stuff and everything. And if it doesn't, then obviously it's an error. If it does, then it will execute and the response will be generated. Again, the response can be matched with the schema, saying that, well, this is exactly conforming to it is actually returning a string and not something XYZ or something like that. So that will be again, so that kind of thing is done using XML as well, and that's the thing that is matched against is called schema. So an example of XML is this. So it's just you start with XML and you have students, and under that you can define multiple students in there. So student is the root, and within that you have got different various student attributes or entities here inside, and each of the entities has some kind of attributes like ID, first name, last name, and values within those attributes essentially. So this represents one student with the name John Smith and ID 123. That represents another student with the name Mark William with the ID 546. So this is how you generate XML if you like, and in the simplest way. Okay, so SOAP is an XML-based text messaging protocol for transferring messages between applications. So SOAP consists of an envelope, which is the header and the body. It also can have additional headers for security purposes and all that, and it also requires a body, obviously. And so data, which is exactly the data that has to be communicated. And if the body can also contain the fault as well. So if something contains an error, there has been an error, either your execution failed or something happened like timeout or anything like that, that will be put in the body itself. So this is how it works. So you've got the SOAP SOAP envelope, which contains your header and the body, and within the body, everything is defined as an XML format. So essentially, it just defines that like your requests, like I'm giving two inputs as parameters, and then put it into inside the body, and then the header, and put it in the. So this is the conceptual one. How do you exactly write one? So you've got SOAP :envelope. Don't worry, we will not be exactly going into this level of writing these kind of programs. This is pretty much auto-generated by when you write your server. You will be writing PHP, but this will be generated pretty much automatically. So don't worry about having to write this kind of this level of complicated stuff by yourself. In fact, these days you don't, because it's very. I mean, if you are writing something this, and this is the simplest one, we'll see some bigger examples. You don't want to write these things by yourself. However, you can find what this means, and then you can probably, that will make it easier for her to parse things if something goes wrong. So the header also contains the session information and authentication, routing, and security information within the header that is required. So in here we have got the SOAP body, so that contains like a function called getPrice, and the item that is being asked for is Apple. So we are passing Apple as a parameter to a function called getPrice, and we're expecting an output in terms of numeric number or something like that. So that's exactly, I mean, it doesn't say here it's numeric, but the request is like this. So it just says that call this function getPrice with the name Apple. And there's some session key information within the header and all those things, which is, you can put in this envelope component here. So how does it work? So SOAP provides something called an RPC, or remote procedure call emulation, to simplify dealing with the XML messaging. So RPC is just at a very lower level. It's just a messaging protocol that can just send any text message from between one node and the other one. And this is like how it does the encoding. We're not going to deep of how that encoding works, but let's just say that when you write your function or write your PHP or anything like that, and then that gets converted to the XML, and then there's some kind of encoding that happens at a very lower level, which is then exchanged at the other end, and that works like this. So we have got a method name that is like this, and like that get, or in this specific function it was the get price, and then we're passing that parameter Apple. In this case it gets time and then local, and then we mention that okay, so we're calling this clock service. This is the object that we have created using the SOAP, and then we're calling this function get time associated with the object, and then we are passing on the parameter here. So that is how that will look as the service request is like this. So that essentially is transforming into a like an XML looking thing that is kind of sent over the network. So get time is defined as a tag, and that will have an end tag as well. And then the parameter inside, we call it as a location. And we defined as type string, so we call it that XSD string, and then essentially the data type as string, and then essentially the actual parameter, the value that we are passing is the USA, which is the country name, and then that is sent back. And then we end it with a path tag as well. WSDL. stands for the Web Service Description Language. It is an XML-based standard for describing web services and their operation. WSDL contains the interface definition part and the implementation part. So the interface definition part, like it contains the message and or defines the message and the parameters, and it also contains stuff like port types, message types, and bindings, all the rules essentially. In the implementation, we essentially just define the exact location of the service, like a URL or something, and then transfer protocol that are supported by that. And it consists of the services and the ports in there as well. Now, this is just a description language, remember. So that's kind of going to be in format of XML again. So if we go with our services definition, we've got something called port types, messages types, binding, and the actual implementation side where we've got services and ports. So we've got operation signatures. So that's like calling something with a name, like that's just a defined port type, and then within that we've got some operation that is defined again, and we call something called a send a message with some parameters like question type or anything like that. This example was taken out of this website. You can have a look into that to actually get a better understanding of where these things are coming from. And then you have got the types, which is defined under the type tag, and then you've got some schema definitions inside that as well. Then we define the transport protocols in here, the transport layer stuff and everything. And within the implementation, we define the service location and contains the name of the service and port list and the service interface binding exactly. So you have got, now we are exactly putting in a web link here using the localhost formula again. Okay, so UDDI, so that stands for Universal Description and Discovery and Integration, and it is essentially XML-based specification that describes a central directory or repository for of simple object access protocol services that are that can be consumed. So you have to like register your service with some kind of like service registry mechanism there. To access, we can use a browser, or we can just use some kind of UDDI APIs. So how we can implement SOAP in PHP? So we use the PHP provides something called a SOAP server and a SOAP client. So if you want to implement a SOAP as a service, so use the SOAP server. If you want to consume something, you go with SOAP client here. In the SOAP server, so that's the format here. So you create a, you mention the WSDL, and then you essentially pass on any arrays, like any optional stuff, like if you want to trace or anything like that. So this allows you to create a server object in either a so you can create SOAP without the WSDL as well. That's what we will be doing in general. But you can do it using the WSDL as well. PHP it's a bit difficult because it doesn't really, it's not very like it's a good consumer but not a very good SOAP server kind of thing. Whereas other programming language like Java and all, you write the code and it just does a lot of things for you automatically. So in this, for the PHP, we'll just go with the norm WSDL mode mainly in the tutorials and all. So if you are using WSDL, you provide the URI of the WSDL, so that will point to some of that XML format and stuff. For non-WSDL, you just put null in there if you are not doing that. But you have to then specify some other parameters instead of that. So the options are like which format of SOAP you want to use, which version, which encoding format, any target of the name SOAP server. If you want to pick a specific server, then you have to put the name there. And if you want to define any specific actors, like if you're using SOAP with actors and all those things, we're not going into that level of stuff. But there's lots of different options that you can configure your SOAP with, SOAP servers with. SOAP client, on the other hand, will have that again, that WSDL or the URI of wherever your service is being executed, or wherever you're going to call this stuff from. And then we have got some pass some options as well, like the SOAP version that is used to describe that SOAP service and all, the location or URL of the SOAP server, and then again URI of any target, any other namespace of the SOAP server and all those things. Now, what this means is that you can, like, this is where that multi-layered architecture concept comes in, is that you could have a SOAP server that is defining some namespace, which means that it could have some object definition and all those things, but your actual object that you are trying to communicate or call could be in another SOAP server here. But this SOAP server standalone may not work, so it may actually need to confirm something with this SOAP server, the URI, before you actually are able to consume it in your client side. Now, this is how you can make things multi-layered and everything. But once again, it's not required that you have to put all of those things. It's actually optional. You don't need to make it multi-layered or multi-tiered as such. Now in PHP, if you want to enable SOAP, you have to, it's not enabled by default. You have to go to that PHP INI, you have to get rid of that colon. You may need to install SOAP as like this as well. It may not be installed as the normal PHP stuff here. So depending upon which version of PHP is installed, you may have to install it like this, sudo apt-get like that. And then you go and change that percentage S or this semicolon in the PHP INI to enable it. And then you can go back and check using the PHP Mindflow or anything like that. Then you can actually see whether it's enabled or not. An example of how this thing actually works. So until now, we just went through a lot of theoretical stuff, most of which is very difficult to code by hand. But let's have a look at the examples. So this code is written in Java, so it's not PHP. But you can see it's kind of conceptually it's similar to what we do in classes within PHP as well. So you declare a class with a name. Web service name is also hello service. And this is a comment that says that it will just say hello, that's all. So what it does is that we implement a method, so that just says that all this can be called as hello. And so we then describe that function here using public string. So this is a public function which will return a type string. The name is hello. It will take a web parameter with the name MSG. So you have to pass your parameter name is MSG, but the string is like in this function we are calling it as txt. So note that here we didn't name it txt. We could have, but it didn't name it as txt. So locally, when we execute this object, we name it as txt. So inside this, in the program level, you have to refer it as txt. But when you pass in the XML stuff, you will name it as MSG. So that's the thing. That's how you can differentiate between like the web service component side of things and what exactly runs in the background in this web service coding. So what this does is that we did return text plus. So plus is like concatenation in Java. In PHP, the concatenation is dot, so you use dot to concatenate to string. In Java, you just use plus. So it just goes text, whatever is passed, and then returned by hello service. So this is returned by the this entire string. Like if you pass XYZ, so it will XYZ returned by hello service, and that's going to get returned as a text to the client side. So this is how the WSDL will look like. So as I said, in Java, it's easy. So you can, if you write this code yourself, the WSDL can be auto-generated. And you'll have this XML format directly. It's actually much bigger. It's not this small usually. So the proper WSDL will be, you will have some other stuff in the top, and then you've got definition name. So that's hello services. The target namespace is HTTP hello service. We don't have any complicated things here. That's why the target namespace is kind of simple. But you could have target namespace like that refers to somewhere else, like a completely different website, like an internet site or something like that. Then we define, this is pretty much the straightforward same thing, that where does this WSDL's definition comes from. So that comes from that website, like the standardization, like this is how we standardize the web service description language. So that is defined in that website. And then you can have like XML schema. These are pretty much standard stuff that is auto-generated. And then within that, the schema location of this specific service is in this location. That's localhost is hello service and XSD equals to 1. And then there is a message that can be passed, which is the name hello. So if you want to call that hello, then there can be two types of message here. So you can ask something that is hello, and you have to pass a parameter in there. And that parameter is also named as hello, this one here. And you can also, there can be a response here. So the response type is defined as like this. There can be hello response with one parameter exactly, and that name is called hello response here. So that's the response that has a name being, this name is being named by the whatever you have in the web service description language. This doesn't, it kind of relates back to what you are trying to implement as part of the web service, but it's not a one-to-one matching. It's not necessarily there will be one-to-one matching with the code. So this tries to define all the messages in here. So that can be passed between the client and the server here. If you had more messages, then you would have a lot more like message names in here. So next is define the port type, which is the hello service, and then we call an operation, which is the function name, that is the hello, and then we go with the what message it can pass, the this hello request, sorry, this hello function, and then we have got an output message which is defined here then as hello response. So if you call hello, you will get a response that is called hello response. That's it. And how to, where is the URL for all of these things? That's the hello service / hello service. It's kind of confusing in the sense that it says hello service all the time, but this hello service comes from the definition name, and that has been defined earlier. So that exactly was the service name that has been defined here, hello service. So that exactly is defined like this. And the target namespace is http/hello service. So that's the target namespace, and then it combines with the definition name or the service name specifically, and then it just calls the function that you want to use, so which is the hello request here. But this is again defined here itself. It's not like something that comes out anywhere. And then the output message that can come up from that port is essentially the which will be the message type, the hello response, and then there will be where you can find that, that's there. Okay, so and then there is the service port binding concept here. So you have got a like hello service which binds to that specific port. And then the message, it's described like the binding style is a document, and the operation name, once again, we say again, it's a hello. So you can see how repetitive it is that you actually have, you define the message type, and then you define the port type, and then we define like again the binding again in here. So it's kind of making sure that nothing is missed. And if you like that, like when we create the class from or object from using this kind of definition, nothing is missed in there. And ultimately, we've got the service name again, like properly define the hello service, and the port name hello service port, and the binding is with hello service port binding, and then got this address location. We define this as the address location of this object here. So this is what we'll be using in our client side. So the WSDL schema will be like this. So it will have an element name, like again with the hello, and the other element name will be hello response, and we define that message that can be passed as string, and this hello response will be the output, and it will return a value that should be a string as well. So this defines the exact schema for this specific web service here, like what we implemented this one. And this is just the WSDL for that one. Okay, so this is how a request and a response will look like. So a request will look like this. You will start with XML. In the envelope, you will have like a link or something, and then we have got a header, and then within the header we'll have a body. So that body will call the hello, and then it will call this service like that. That should match whatever the name was here. Sorry, here, that name here. And then we send this request, this is my message and all those things. And so that gets sent, and what the response comes out is that my message returned by hello service. And on with that, we have got all this attachment in the top and bottom. Okay, so now how do we consume this service? So if you did, now we are moving to PHP. So we now define where our service is, which is the HTTP blah 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 and like slash WSTL. So this is exactly that came out of this one here, and we just put the question mark WSTL. So that's the format, how to saying that it is actually WSTL and not a non-WSTL service. So yeah, so we define a website here. So like it's essentially a URL or URI here, and then we pass that into here, and then we in here we are just saying that trace the link as well. We could have just not passed anything, that was possible. And this is defined as a web SOAP client. Now we pass a parameter that we make an array of the of whatever inputs that we are trying to pass in. Now it has to be an array. That's what the PHP requires. Even if it's just a one parameter, you have to make it as an array. Okay, so and then we use a try catch. So try catch, we use try catch just to make sure that if there is any error, it doesn't crash the entire PHP. And if there is an error, we try to know what the error is, the output. And so we call this SOAP client, and we call it as if it was a function here. So we can just call SOAP client goes to hello, and then we are passing the parameter here. And then we go echo SOAP request. You can just see the request that you just made. So in PHP, you see there is nothing that you have to worry about. You can, I mean, it's all already done. When you make this thing out of that array, like from this web service WSDL, PHP automatically converts everything to a client, and then you can essentially call it directly here. And then you can go SOAP client, and you can see the last request, what you saw, like that will print out something like this. And then if you go echo response, what the response you got, you can call this get last response. You'll see what the last response it got from there. And you can also like go result as well, and like that, and you can see the result from there directly. But if you call this, if you call the echo, put it there. If you go echo of this directly, the SOAP client hello, you will just get that little bit there. You just see this thing in your output there. This is what we'll be doing in the tutorial. Any questions until here? I guess there will be a lot of questions regarding this part here, but let's not go into depth of how this structuring occurs, because that's a very, very complicated thing that will probably take 2 lectures to finish if we go into depth of how this thing is constructed actually. You can always go to the just somewhere put the web link to the IBM website where you can find more details on how these things is constructed and how this thing works. But we are mainly concerned about how we can consume this thing in a PHP if we declare it in Java web service. Okay, good. So in another example, in the non-WSDL mode, so if we write everything in PHP, then we can use the SOAP server as in a non-WSDL mode as well. This is not standard, but we can. It's kind of makes it easier to implement and use. So what you can do to implement a SOAP server is that you declare class. So you declare hello service, you declare a function construct is empty, and you declare a function hello $msg, and then you go msg and then append return by SOAP server for hello service. So this is exactly the same, doing this pretty much the same thing as this one here. It's written in Java, but it's written in PHP, and it will not use any kind of WSDL. There will be no web service description language or anything like that. There's no document associated with that. So we create this one, and then what we call is that we pass as null. So we are not using any web service description language here, and we pass we have to pass something called a URI just to pass it. We are not exactly, in this example, we will not find that there is anything that is changes from anything. And then we can set class. So we just say that for accessing, or if we get a request, then how do we access this thing? So we can go to this, we just set this class as this one. So you could have multi-layered class. So you could have another class which is inside this class and all of those things. But the class that will actually handle any SOAP request is specifically the hello service request here. And then you just call the handle function to make it like to start listening to any incoming request that comes in. So this is like a pretty standard architecture to create a SOAP within just using PHP. Now, if you go with the client side, so okay, so you can declare an HTML stuff on standard PHP stuff, and within that you can define some kind of HTML form and all those things to take your input from the user and press submit button, all those things. However, when we get the message, then we can call something like this. Is actually the key part here. So if we go SOAP client, we can call it the SOAP client, and we go null, and then we mention an array with the location. Now, this location is different. Now, this is the wherever your PHP exists. So now this is very important. This is where this link should be where your PHP actually exists. So that's soapserver.php, which is this file here, and the location of that one should go here as under the location tag here. And this URI, we're not actually mentioning. So this there's nothing on utest.edu.au. It's just something that we have mentioned as, because we are not creating any WSDL or anything, that any description component or any schema or anything like that for this application here. We have to mention something that we are just putting something here, and that has to match whatever we put here. Sorry. Yeah, so that has to match this one. Yeah, so this is exactly, this should be the same thing as this one here. However, nothing exists. If you go and type that utest.edu.au/hello w service, nothing will actually appear. And that is simply because we are not defining any additional component to that SOAP service in there. So then we can call the return message equals to, we just call the function SOAP call, and we pass on hello, and then we pass the message in there. So that's how we can call a web service like this. Pretty much similar to the previous example, we just use this SOAP call to call the hello. You cannot actually just call hello like that. We have to call the function SOAP call, and then we have to pass the function name like this, and we have to pass the array of elements that we pass, array of the parameters that we want to pass within the hello to the function. So this line is pretty much the same as this line here. So it's same as there, but here you can call the function directly as a function and then pass the parameter like a normal one. But here you have to call, use this __ SOAP call function, and within that you have to mention the function name and a comma with the array of elements like that. Okay. All right. So then we go echo return message. So this will just give the output like whatever was returned from there. Okay. Any questions? Okay, so the next is RESTful web services, which is a more open-ended than SOAP. So in SOAP, as I mentioned, the main formula is that you define an object and then you essentially as define a class and then call an object for that class, and then you kind of try to call back your functions, and the entire architecture of the SOAP is to ensure that the functions and parameters are passed correctly, and the output, what we get back, is defined correctly as part of the description language and schemas and all of those things. The RESTful, on the other hand, is more broad and open-ended, so it can very easily transfer stuff within JSON and XML or any other format, essentially. REST is like it just uses directly the HTTP concept here, and it just use common operators like get, post, and put method like before. So we don't really have to like go through this complicated set of like creating subject objects and then attaching it with some service and all of these things. We don't really need to do that if you're using REST services directly. However, the main issue with the REST is that because it's open-ended, it's much more like you have to spend a lot more time doing maintenance of this kind of services to make sure that it actually keeps working. So this is based on the resource-oriented architecture concepts as such. So the concept here is there is no registration concept here. You can see like it's very much like the client server kind of thing, where we have the client and put a HTTP request, and then we get a response back in a JSON, XML, or HTML format. This is REST is, you can think of it as pretty much like calling something through AJAX and stuff like that. It's very similar to that, but it's just not just any PHP. You still follow some kind of formatting in there. That's all. So what does REST do? So you can have like it's a client server model concept. So there is a separation between the user interface and the data storage thing, and it's stateless. So each request from the client to the server must contain all the information. So there is no session concept here, and it's cacheable. So you can actually store the last whatever you had stored somewhere in an intermediate server if you want to. However, because it's stateless, you still have to pass on the parameters that you actually need. You cannot just rely on cache. Uniform interface. So you have to have the URL properly defined, and then you can access your like whatever you are trying to get from the server or the service. Layered system, so it can allow for multiple layers of services. So you can call something as /x, and then you can put /x and x2, and then /x2, x2, and then /x3. Like you can actually go deep within each of the like you can just expand the same link into more depth stuff. Like pretty much like if you create a folder within the your public underscore HTML, or if you're in your bar/HTML, and then you put a folder in there and put a folder in there, you can actually access your website, and then /folder name that will go into one level, /folder name it will go into another level, and then /folder name it will go into another level within your website there. So that's exactly how you can create a layered system within the RESTful concept as well. It can also provide with code on demand. So your client can be extended by downloading and executing code in form of some kind of small scripts and all. It's also possible with the RESTful web service. So if we have got a web service called customer, so you can call that, the client can call that from the web service, and the methods will be something like post, get, put, or delete. Post means this is exactly conceptually it would be the same as the previous one. So post means that you can create a new customer record. You can use the get to get all the customer records from there. You can use put to change any existing customer, and you can use delete to delete any existing customer from the database and all. So you can create different functionalities like this attached to each method of calling and all those things with the web services. Now, how to do that with PHP? You can use curl init, which is a function in the PHP, and you can use the curl set option to set any option, and then you can call curl execute to actually get the curl output, and then it just close the function. So you have to call all the four one after each other to make one transaction, like to get something like send an input and get an output of a web service. So in it, you can initialize it with some variables as well if you want to, or if you want, you can set some options in there. And if you want to go with like when you are executing, you essentially call the /xyz or something like that. So essentially the exact resource location that you want, and then you can close the resource. So this is an example of a RESTful web service, which I think is a tutorial as well. So you have to ask for a web service that returns the, you pass the name of the like the monument, and then you get a reply back where that is situated. So we create a directory structure with this called function.php, RESTful PHP client.php, and RESTful service.php. So that's how we create the PHPs in a single directory, and then we create the function like this. So function.php contains the exact function that we are trying to execute, that is like wonders where it is located. And if empty, like this is standard PHP stuff, and then you essentially return on the place like where it is located. As a RESTful website service example, so we essentially now we define this output as a JSON. So whatever we want, we'll have the output as a JSON. If we wanted, we could have made that XML. And the only thing that we have to make sure that if we declare it as JSON, our output also should be JSON. So we should be echoing a JSON as well. So we include that function that we had before, and then we have got like we accept the parameter from the user here as $_get wonder name, and we put it in a variable. We pass it in the function declared earlier. You could define object in here as well. You could have defined an object in here, and you could have created an object here, and you could have like asked for an object function with a parameter like the wonder name as well. That is also possible. However, the RESTful client server doesn't worry about the object at all. It doesn't care whether it's an object or a function. It's just going to call and get stuff in directly. Directly means that it's just going to like call a web link and then just essentially pass a parameter that will need to be as an input, and then it just gets the output and displays it. That's literally how it works. So if empty places, which means that we didn't find anything, now we have to sort of, because this is acting as a server, so we need to respond with something. So if we say that if this service didn't find any like valid answer, then we say that 200 means that the request was correct. However, there is nothing to show as output. So we say that wonder not found. Otherwise, if the place has been found, which place that is located, then we say we return 200, which means the request is correct, the response is also okay, and we send that the wonder found, and then we return the place here. That's exactly how we send the response back here. So deliver response essentially creates a puts everything as a like the packaging, all the HTTP stuff in there, like the packet stuff and all those things, and it just returns as is directly. So you don't really have to write everything as individual, like the headers and stuff in the HTTP by yourself. It just does it for you. So the first one is essentially the return this HTTP state that you are trying to return. So if it's for 200, then the execution and everything was all correct, and then we are just depending upon whether we found a place or not, we are returning different entities, like different outputs back to the caller. this else is against this one. So if the user did not pass this wonder name now, because that's an invalid request completely. So if they pass a wonder name, that's a valid request, but no output. But if they didn't pass any wonder name at all, that has to be searched, then what happens? Then it is a 400 error, which means that you are telling your client that, well, you did not put a proper request, so it's a 400 error, which means that there is nothing to return as such. Now, this is how you should logically structure it. You could have sent a 200 here as well. I mean, there's nothing stopping you from writing a 200 and saying request not valid, but that's not the proper output that you should have on like for this kind of scenario, because your business logic or the way you are writing this, the application logic is expecting that you should be passing a parameter here. If you don't pass the parameter, it's a broken thing as such. It's not shouldn't be considered as a correct thing. So this delivery response is written. It's like this here. So you have got the header. We set the header, and we just say the status code, status message, and those things, and then we just send it back here. We JSON encode everything, and then we just send it out here. And this is an inbuilt function, the JSON encode. So that's essentially like creates a JSON encode out of like JSON format of this entire thing of the response. And then we just go echo. Now, one obviously important thing is that there should be exactly one echo in here as well. So that is the response that you want to show as an output. If you have any other echo 1, 4 or something like that, that means that your output is corrupted. So it will not be passed correctly on the other end. So you have to be very, very careful. There is no echo. If you are doing some testing, you might, but if your final output should not have any other echo or anything in this example here. Okay. So we have got this echo response output, and then on the client side, what we are doing here is we set the Colosseum. So where is that parameter, and then we pass a URL. This URL is essentially the RESTful service PHP, and then we pass this parameter wonder name with the parameter that we're trying to get. We go client CURL init of this URL, and then we go echo, and that thing is go some. We set some input parameters for this client, and we go CURL of and return transfer. That is one of the options that you can have. And what was one? I can't remember what was one. And then you essentially go CURL execute. So you are essentially now sending the request here, and whatever output comes in, you put that in the response here. Now, when we get that, we have to run JSON decode. So that's just the opposite of encode here. So when you go decode, you will get a more proper output as what was the result. And then you can go call something like result colon results. And this is because this result is sent as a result here. So whatever is name you use here to store the data, the rest of the stuff is static because they are part of the HTTP protocol stuff and all those things. But you can change these results to anything as such. And then that will be reflected here. So you go result of result, and then you can see the output as like whatever the exact country name that came back. So in this case, it will show Italy like that if you ask for that. Okay, so any questions? Okay, so just a comparison between SOAP and REST. So SOAP is like, it's actually a proper protocol. REST is not a single protocol. It's really based on the HTTP, but it's just layered architecture style that's of accessing some things more directly rather than using a very complicated, well-described protocol. So this is function-driven transfer structure information only. This is data-driven and access resource for data directly. This only uses XML. It may have some other format somewhere, but the main structure is always XML. Like as you saw in the examples, everything is essentially XML. Like the description language and everything is always in XML. And the REST is always like it's very flexible. It can pass anything. Like you can pass on plain text, you can pass on HTML, XML, and JSON, anything like that. We use JSON in this format, but we could have just put everything, our output as an XML as well, and consumed everything as XML on the other end as well. That's also possible. Security, so for this one, you require, both of them are well secure. There's no issue with security as such. It's just that with SOAP, we have some additional methods of ensuring security. REST is anything that goes with normal HTTPS can go with REST as well, like simple SSL and HTTPS concepts here. Bandwidth, so requires more resources and bandwidth, which means that obviously because you are now like, you can see that just for calling that simple hello world example, how many millions of lines of code you had to write. Yeah. So just to describe this thing here, we had to first define our like this entire thing here, and then we had to define this entire thing here. So literally, it's a very complicated way of describing things. Like it just adds a lot of different like the additional stuff in there. So which means that all of this has to be extended on the network as well. It just makes it more data, like more data intensive in general. So which means that more bandwidth. So this is much more lightweight in general compared to this SOAP. None of them can, so this can be cached, so SOAP cannot be cached and REST can be cached. So this has a very strict communication contracts and needs knowledge of everything before by interaction. No knowledge, you don't have to know anything about the REST API or any kind of REST web services. So with the SOAP, you really need like a booklet or something like that to define, well, this is there, so you can actually call this function or everything like that. REST, there is no registration or anything like that in the REST concept here, but within the SOAP, it has to be properly defined, register somewhere. ACID compliance. So ACID is that atomicity, consistency, integrity, and durability concept that we had for databases, and also SOAP can support that because it's because everything is implemented in classes. There is pretty much no way of anything going wrong. So everything will work as is. There's no problem. Whereas within REST, it's more on the developer, individual developers to make sure that things are correct. For example, with the REST, if I made this to a 200 instead of 400, that will still work. There's nothing stopping it from the services to work. However, that is an error essentially. Like if your client doesn't know that whether it should be getting a 400 or a 200, then they can misinterpret the response. That's the problem. Because there's no way the CURL opt can actually, like whoever is calling this function will know that whether if we do not pass a parameter, what should we receive, 400 or 200. So that's kind of thing that has to be defined by the people implementing the services. However, it is still possible. You can like it's not a problem if you don't pass it. You can like you can see what your output you get, and then you will know, okay, we have to pass it, then you pass it, and then you get an output like that. So it's possible to know it, but it's not inherently doesn't implement any of the ACID compliance and stuff and like that. Okay, so last bits here. Any questions? So conceptual stuff again. So I've got web service security step. This is just we put on top of the SOAP. So what kind of components we need? So we need some kind of secure conversation, conversation like the security context between parties, like how you exactly want to, like what kind of thing you want to pass between parameters and all. And then you have got the federation, means that extends the trust to a lot of different organizations and their authorization, like who can access what, like which services and all that. And then with web service security policy, you need to have like everything defined, otherwise the SOAP method will not work. And the trust, which defines the trust model for maintaining the relationship between the web services. So if we have multiple web services, then like consuming each other, then who can consume what and up to what level on these things. And also privacy constraints. So like, once again, this relates to the visibility of web services to who can see it and all those things. So these are all the security components that you can put on top of the general SOAP XML stuff that you saw earlier. This is where what makes SOAP a bit more powerful than the rest here is that it kind of implements a lot of these additional business to business kind of concepts here, which is hard to implement with REST protocol because there's nothing like this on a SOAP I mean, there's nothing inherently that you can put on the REST here that actually will work out of the box. So for the REST, there's a for the REST web services, the security is not that. I mean, it depends upon the person who is, or the company who is trying to make this thing. Like, they have to think of how they want to do it, and they have to make sure they understand each other as such. So there is a lack of like message security layer. So like, there is no way to define what kind of messages are going back and forth. And there is also like the lack of high-level security concept, like the conversation and the trust and other kind of concepts here. All of these are essentially like, you have to implement it separately without having any like a full like well-defined structure like we have in the SOAP-based stack method here. However, obviously, if you are running a web service between two, three different companies, then you want to have all of these anyway. And this is kind of one of the issues that we have with REST, is that it's difficult to implement stuff, and it doesn't make it scalable if you have multiple companies trying to then understand what was implemented before. Whereas in SOAP, it's much more easier because you can just call an object from anywhere, and it will work in the same way for any client and any server like that. Okay, any questions? I think today's discussion was pretty boring, pretty elaborate, and very tech oriented, I suppose. Most of this thing will become clear when you do the practice, to be honest. And we are not really going into much depth of like how those WSDL and stuff is actually created. It's way too complicated to do in one unit, and most of those things you don't do it by yourself. You actually let the software stuff do it automatically. So any questions? So what happened? Everybody's bored or something. Oh, good. I guess then we can end the discussion for today. Okay, so I guess, yep, we'll just end to the discussion. Yeah, one thing is that regarding what you can expect from question is, this is, as I said, this is, the first part is more conceptual, and that's what we are going to focus in here. This thing is covered mainly in your assignments as such. It's not a more This is not going to be more in the final exam concept here, except like maybe like difference between SOAP and like REST kind of thing, or things like that, or what are the components of the, say, like SOAP. Like then you have to go into those 4 components that we have and describe like with some examples in there. However, most of this, whatever we do, is more practical oriented stuff that we do. You have to implement in your like in your assignments that you do. I think not in assignment 1, but in assignment 2. Yeah. So consultation time. This link is the consultation you can use it for. Like I'll be online on. Did I publish any consultation time? Oh no, I think there is a consultation link specially that I made on. Yeah, I made a special link that I should be online on the Monday 1 p.m. or Tuesday 1:30 p.m. However, just to note that I am coordinating 2 units and my consultation time is kind of split between 2. So yeah, if you have any questions, just send me an email beforehand. One other thing that we can do is that you send me the questions and we could have like spend about 10 minutes every week at the beginning of our lecture, so that I can sort of like explain a few things in the beginning. That would be much quicker. Yeah. Okay. I'll put it on the Milo somewhere. Sorry. I changed my consultation hour details on the website somewhere. I don't know if that's visible to everybody. It should show up with this link somewhere. But yeah, I'll put it in Milo. Okay. So yeah, regarding questions, yeah, that's what I meant about the like you get more like a 1 or 2 theoretical stuff from the list and SOAP stuff. Okay. Any other questions or anything? Otherwise, we just say goodbye today. This is my shortest lecture this semester so far. Okay.